Imagine you have three identical-looking clear liquids in front of you. You know they are all alcohols, but one is primary, one is secondary, and one is tertiary. On the surface, they look and smell exactly the same. How do you tell them apart using nothing but a few chemical reagents and a splash of color? This is where the Victor-Meyer test comes in. It's a classic piece of chemical detective work that uses a sequence of reactions to turn these clear liquids into a vibrant RGB color code: red, blue, and colorless. Let's walk through the lab bench together and see how this works. To start, we need to make these alcohols more reactive. Imagine we're priming the molecules. We add phosphorus and iodine to all three test tubes. Notice how the hydroxyl group, that OH on the end, is swapped out for an iodine atom. We've now converted our alcohols into alkylides. Next, we introduce silver nitrite. As we drop it in, the iodine leaves and a nitro group takes its place. Now we have three different nitroalkanes. Up to this point, all three tubes still look pretty much the same. But here is where the real magic and the chemistry starts to diverge. We add nitrous acid to the mix. Watch closely at what happens at the molecular level. In our first tube, the primary alcohol, the carbon attached to the nitro group, still has 2 hydrogen atoms to spare. The nitrous acid attacks these hydrogens, stripping them away to form what we call nitrolic acid. In the second tube, the secondary alcohol only has 1 hydrogen atom available on that central carbon. It reacts differently, forming a molecule called pseudonitro. And in the third tube, the tertiary alcohol has no hydrogens left on that carbon. It's completely blocked. The nitrous acid has nothing to grab onto, so absolutely no reaction occurs. Now, for the grand finale. Let's make the solution alkaline by adding some sodium hydroxide. Watch the first tube. As the base hits the nitrolic acid, it suddenly flashes a brilliant, deep blood red. This is our positive ID for a primary alcohol. Look at the second tube. The pseudonitro reacts with the base to create a striking, sharp blue color. That's our secondary alcohol. And the third tube? It remains as clear as water. No reaction, no color change. That's the hallmark of a tertiary alcohol. It's often helpful to remember this using the RBC mnemonic: red, blue, and colorless, corresponding to primary, secondary, and tertiary. But here's the key insight to take away. The Victor-Meyer test isn't just a magic trick with colors. It's a celebration of alpha hydrogens. The entire test depends on how many hydrogen atoms are sitting on that specific carbon atom tied to the functional group. It's a visual reminder that in organic chemistry, it's not just about who is at the party, the oxygens and nitrogens, but also about who is missing. Next time you see a clear liquid, remember Victor-Meyer. Sometimes the most colorful secrets are hidden in the smallest atoms.